Hello everyone, and welcome to week 2 of Summer eSchool for Math 2. So at the end of last week, we started our journey of learning how to factor something, right? And in that factor, we spent a lot of our time, actually our whole time, learning how to factor quadratics where this a term here is equal to 1, all right? And if you guys recall from last time, how we did that was we took a, which is 1, and we were looking for a number that multiplied to be c and added to be b, leaving us with our factors as x plus or minus some number times x plus or minus some other number. Now, this week, right, our focus isn't going to be so much on that particular method of factoring. For this week, we're going to work with another method. All right, what we're going to do is we're going to take a quadratic where the leading coefficient a does not equal 1. It equals something non-1, so 2, 3, 4, anything really. All right, and we're going to try and factor it. Now this takes on another level of complexity, right? Because it adds this one extra step to our process. So before we get started, like last time when we were doing quadratics, we dealt with two distinct methods of doing it. We dealt with this idea that you could use the box to make it a graphic organizer, or you could do it just by, a more streamlined approach. So let's go ahead. I'm going to go through the first method by doing it with the box, and then I'm going to go through the second example using the method that I created. All right, and then we're going to go through the last one with a box as well, and I'll go through both for that one. Okay, so we have 3 examples. Hopefully this is helpful. Remember, this is going to be posted under the direct instruction of our module for Monday, and if there aren't any questions, we're going to go ahead and get started. Okay, so using the box, we're going to do a very similar thing to what we had done before. So let's go ahead and create our box here. All right, remember up in that first corner, is going to go the first term. Now, this is really important because that first term no longer is just going to be x squared. So we're actually going to have, for this one, it's going to be 2x squared. And in the bottom, we're going to have 3. All right? So what we're looking for here, everyone, is we're actually looking to decompose the 7x. We're going to actually break 7x into 2 distinct factors. So we multiply 2x by 3x. Okay, that gives us 6x squared. All right, now that we have 6x squared, just like we had done before, we're going to look for factors that multiply to be 6x squared, but add to be 7x. Okay, like we had done before, we're going to go ahead and start with 1. 6 times 1 is 6. 6 plus 1 is 7. So that actually works in our case. Remember, I start with 1 because it's the easiest way to standardize where you start with each factoring example. Okay, so we take 6x and we do, 6x times 6x, or excuse me, 6x times x gives me 6x squared, but 6x plus x equals 7x, all right, which is what we're looking for here. So what we're going to do, all right, is we're going to take this factor here, this question, and we're going to break it up. So let's go ahead and we'll put 6x here and x here, all right, and we're going to break this up. We're going to say now we can rewrite this as 2x squared plus 6x plus x plus 3. Notice that we didn't change anything here. This 6x plus x is still equal to 7x. So really we just rewrote this by decomposing 7x into the 2 factors we know it must be equal to. Okay, now we do something that's a little bit tricky. We're going to group our 2 terms and pull something out, and hopefully we end up with a common factor. All right, the easiest way to do this, guys, is just by practice, practice, practice. So let's go ahead with an example here. Let's do 2x squared. I'm going to group 2x squared plus 6x plus x plus 3. All right. Now, the next thing you're going to do is you're going to want to pull something out of this term over here. So let's say I know I see a 2 here. 2 goes into 6 3 times. I see an x. I can take the x out as well. That leaves me with 2x times x plus 3 plus x plus 3. All right, now this is what you're looking for here. You're looking for when you pull a variable or a number out of this term here, or that term, depending on which one. You might have to do both. That you're looking for these two terms to match. So this matches with this. Because what this allows you to do is to factor by grouping, which allows you to do, this is 2x plus 1, all right, which is 2x plus 1 times x plus 3. So you take this term and add this term to create this term here, 2x plus 1, and over here you just keep this x plus 3, right? Because if you think about it, if you distributed this x plus 3 into here, you would get this same thing. You'd multiply the x plus 3 times the 2x to give you 2x times x plus 3, or the x plus 3 times the 1 to give you just x plus 3. And now everyone, we're actually done, and these are our factors of this quadratic. There's this 2x plus 1 and x plus 3. So that's the first method of doing this. And the second method is very, very similar, except I just don't draw the box to do it. All right? So 2x plus 1 times x plus 3 gives us our answer here. And I did that by factor by grouping. All right? So let's go through another example. All right, that I wrote out here. We have this 3x squared plus 10x plus 8. All right? So step 1, I'm going to multiply a by c. So a times c is equal to 3x squared times 8. 8 times 3 is 24. So we keep the x squared there. This leaves us with 24x squared. 2, we need to pick our factors where we're looking for factors of a times c where the two factors, we'll call them x plus y is equal to b. All right, well, these are our two factors, okay? Well, actually, we can make that a little clearer by saying where factors of a times c where they add to equal b. Okay, so for our example over here, we're looking for two things, 24x squared, that multiply to give you 24, but when they add together, they are going to equal 10x. Okay, so let's go through our numbers just like we had done before. Okay, we say, okay, 24 divided by 1 is 24, so 24 times 1 works. But does 24 plus 1 or minus 1 give you 10? No, right? 24 plus 1 is 25. So we go to the second one. What times 2 equals 24? All right, 12 times 2 is what we get for that. And we notice that maybe that might work, because I know that 12 minus 2 is 10, but everything's positive here, so I'm like, I don't think that's going to work either. So try 3. Okay, what times 3 equals 24? That'd be 8. 8 plus 3 is 11, so we're getting really, really close. I have a good feeling about the next one. 24 divided by 4 is what? You should get around a 6. So 6 times 4 is 24, and 6 plus 4 is 10. So we can break this into 6x and 4x, where 6 times 4 is 24, x times x is x squared. So we mark that off, and 6x plus 4x equals 10x. All right? So we've done that step. Now 3 is going to be rewrite. All right, we're going to rewrite our quadratic. All right, where we split b into its factors. Okay. Okay, so when we write this out, all right, we're going to rewrite this as 3x squared. Now, I'm going to give you guys a tip here, okay? I want you to split this up in such a way that the two numbers that you put next to each other, so I have a choice here. I can put 6x plus 6, or 3x squared plus 6x, or I can put 3x squared plus 4x. But I know that I'm going to want to pull something out, right? I know I'm going to want to pull some common factor out of these two terms, so we'll put 6x because I know 3 and 6 are very common factors with each other. 3 times 2 is 6, right? I also know that 4 and 8 are very common as well. So that's the way I write it. Now, If you make a mistake and say you write 4x and then 6x and you notice you can't pull anything out and nothing's working, just swap these two around, all right? So we're then going to group, okay? We're going to put this as our last step, which is 4 factor by grouping, all right? And what we're doing here, remember we did this in the first example as well, we're looking for, all right, to be able to pull a number out of each term so that two terms match and we can factor by grouping like we've done before. So I see right away what comes out of 3x squared and plus 6x squared. If I take a 3x out, right, because 3 goes into each one of these and x goes into each one, I can pull a 3x out and then I can multiply this by x because 3x times x is 3x squared plus 2 because 3x times 2 is 6x. Now what about over here? I know I want to get something like this, right? I want to get the same term here over here. So let's pull out a 2, or a 4, excuse me, right? Because I know 4 times 2 is 8. And then I just write 4 times x is x plus 2, because 4 times 2 is 8. And we're back to where we wanted it to be, right? Excuse me, this should be 4 down here. So 3x times x plus 2 plus 4 times x plus 2. Which remember, we can take this term and this term to make one of our factors. So 3x plus 4, and our other term is x plus 2. All right, so 5 is going to be right out the total factors, which are going to be 3x plus 4 times x plus 2. Now everyone, I'm not going to lie and say this is something that you're going to grasp right off the bat. This is definitely something that takes practice. That's why we're going to split this into 2 days, and we're going to have plenty of practice with this material. All right? So let's go ahead and do our last example, all right? 3, okay, and I'm going to do this using the same method I just did. Remember, feel free to use the box if you feel more comfortable doing it that way, all right? So I'm going to take, all right, A times C is equal to, this is A, and this is C, all right? So let's actually do this with the box method. I like the box method, all right? So let's go ahead. We're going to create our box. All right. Remember, in the upper left corner of the box, we're going to put our 6x. Excuse me. Our 6x squared. And in the lower box down here, we're going to put our last term of negative 4. We multiply them together, the first and last term. That's going to give us 6 times 4 is negative 24 now because we have a negative sign. So negative 24x squared. All right. And remember, we're looking for two numbers that when they multiply together, they multiply to be negative 24, but add to be negative 5x. All right. So let's go through the terms. Okay. Right off the bat, I know that 24 and 1 isn't going to work. I also know that 12 and 2 isn't going to work because 12 minus 2 is 10, all right? But what about 3 and 8, all right? 8 times 3 gives you 24, all right? And I know the difference between 8 and 3 is 5. Now, remember how we did this last time, right? I know that the bigger number has to be negative, okay? So let's go ahead and try this as 3x plus negative 8x, okay? 3x plus negative 8x is negative 5x. That works. And 3 times negative 8 is negative 24. X times x is x squared. So we've factored our problem here. All right. Now, the next step, right? And remember, guys, this tip here about choosing which number needs to be negative. If there's a negative in front of the second term in your quadratic, you know the bigger number has to be negative. All right. All right. So let's rewrite this as 6x squared. Now, are we going to put the 3 here? Or are we going to put the 8? Right? That's the tricky part. So I know 6x squared and 8x, they have a common factor as well. You can pull out a 2. But I don't think that's going to work. Right? Maybe it will. So let's go ahead and give it a try. 6x squared minus 8x plus 3x minus 4. Okay? I group my two terms like this. All right, now I'm going to want to pull something out. Okay, so let's try. Let's pull 3x. Let's see if we can get something out of this one. So what am I going to pull out of here? Let's say